does this device have the capacity and potential to transform people's lives in the current state? And if not, what are the gaps? And if there are gaps, how do we solve them most efficiently? So that's what I'm very excited about for the next sort of year or so of clinical trial operations. On the technology side, I'm quite excited about basically everything we're doing. I think it's going to be awesome. The most prominent one I would say is scaling channel count. So right now we have a 1,000 channel device. The next version will have between 3,000 and 6,000 channels, and I would expect that curve to continue in the future. And it's unclear what set of problems will just disappear completely at that scale, and what set of problems will remain and require further focus. And so I'm excited about the clarity of gradient that gives us in terms of the user experiences we choose to focus our time and resources on, and also in terms of the even things as simple as non-stationarity. Like, does that problem just completely go away at that scale, or do we need to come up with new creative UXs still even at that point? And also, when we get to that time point, when we start expanding out dramatically the set of functions that you can output from one brain, how to deal with all the nuances of both the user experience of not being able to feel the different keys under your fingertips, but still needing to be able to modulate all of them in synchrony to achieve the thing you want. Mm-hmm. And again, you don't have that properly set to feedback loop. So how can you make that intuitive for a user to control a high dimensional control surface without feeling the thing physically? I think that's going to be a super interesting problem. I'm also quite excited to understand, do these scaling laws continue? Like, as you scale channel count, how much further out do you go before that saturation point is truly hit? And it's not obvious today. I think we only know what's in the sort of interpolation space. We only know what's between 0 and 1024, but we don't know what's beyond that. And then there's a whole sort of like range of interesting sort of neuroscience and brain questions, which is when you stick more stuff in the brain in more places, you get to learn much more quickly about what those brain regions represent. And so I'm excited about that fundamental neuroscience learning, which is also important for figuring out how to most efficiently insert electrodes in the future. So yeah, I think all those dimensions I'm really, really excited about. And that doesn't even get close to touching the sort of software stack that we work on every single day and what we're working on right now.
Yeah, it seems virtually impossible to me that 1,000 electrodes is where it saturates. It feels like this would be one of those silly notions in the future where obviously you should have millions of electrodes, and this is where like the true breakthroughs happen.
Yep.
You tweeted,
"Oh,
some thoughts are most precisely described in poetry." Why do you think that is?
I think it's because the information bottleneck of language is pretty steep, and yet you're able to reconstruct in the other person's brain more effectively without being literal. Like if you can express a sentiment such that in their brain they can reconstruct the actual true underlying meaning and beauty of the thing that you're trying to get across, the generator function in their brain is more powerful than what language can express. And so the mechanism of poetry is really just to feed or seed that generator function.
So being literal sometimes is a suboptimal compression for the thing you're trying to convey.
And it's actually in the process of the user going through that generation that they understand what you mean. Like that's the beautiful part.